In this video, I'd like to continue talking about the complex plane and the polar form of complex numbers. And remember that for some complex number z, that its polar form is equal to the absolute value of z, its modulus or its magnitude, multiplied by the cosine of the angle measured relative to the positive real axes, plus I multiplied by the sine of that angle theta. And for this problem, we essentially need to plot our complex number z based on its magnitude and its direction, this angle of 307 degrees. And we can get a rough idea of where it should be since it's almost a 360-degree angle, but it's slightly less than that. It is bigger than 270, which would put us on the negative imaginary axis. So it's probably somewhere around here along this line, maybe a little bit less or more. And it has a magnitude of 5, so we can roughly guess that it will probably be somewhere around here. But to confirm that, we need to actually calculate what the real part and the imaginary part actually are. Since this is polar form, but if we write our complex number in rectangular form, then z would be equal to a plus I times b, where a is the real part and b is its imaginary part. And of course, I is just the square root of -1. So let's rewrite our equation. We have that the complex number z is 5 multiplied by the cosine of 307 degrees plus I multiplied by the sine of 307 degrees. And we will distribute the 5 to each of these. And remember, 5 is just the magnitude, the modulus or absolute value of the complex number. And this complex number z will be equal to 5 multiplied by the cosine of 307 plus I times by, 5 multiplied by the sine of 307 degrees. And this part right here, this is our real part. It doesn't have I in it. And this part right here is our imaginary part. It does have the imaginary unit. And at this point, we will need to use our calculator. But once we do that, and make sure your calculator is in degree mode, and we will find that 5 times by the cosine of 307 is roughly 3, since we're rounding to the nearest integer. So we get 3 here. And when we evaluate 5 multiplied by the sine of 307 degrees, we roughly get -4. So this complex number z is approximately 3 minus 4 times I. And we can graph that point. We find a real part of 3 and an imaginary part of -4i, putting our complex number here, which makes sense. Because if we look at the angle, we can see that this is roughly 307 degrees. It's bigger than 270 and less than 360. And if we use the Pythagorean theorem, we can construct a right triangle here where we have a 3, 4, 5 right triangle. So it does make sense that our magnitude is 5 and this angle visually makes sense here. Though if we wanted to, we can confirm the angle using the formula that theta is equal to the inverse tangent of the imaginary part divided by the real part. And if we put these numbers in, we will get roughly 307 degrees. Now let's look at one final example problem where, again, we're given this complex number in its polar form and we need to approximate it with its rectangular form. So let's start by rewriting this number. We have 5, and I will distribute from the beginning. We have 5 multiplied by the cosine of 15 degrees plus I multiplied by 5 times by the sine of 15 degrees. And this right here will be the real part of our complex number, and this part here will be the imaginary part of the complex number, where z is a plus I times b. And since we are given this in its polar form, we know the magnitude or the modulus of the complex number is 5, and its direction is 15 degrees. And again, this is measured relative to the positive real axes. Now at this point, we just need to simplify everything, meaning that we can just plug this straight into our calculator to figure out what A and B are. And what we find is that our complex number Z is equal to 4.8296. We can just say 4.83. And we are approximating here since these would be irrational numbers. And we will add I multiplied by 5 times the sine of 15 degrees. But after plugging that into our calculator, we get 1.29 approximately. And it looks like these answer choices round to the tenths place, meaning that we can rewrite these as 4.8 plus I multiplied by 1.3. And looking at our answer choices, we have a positive real part, 4.8, and a positive imaginary part of 1.3. And if we want, we can check this using the formulas we know for the magnitude or the modulus of a complex number. This is the square root of the real part squared plus the imaginary part squared. And we know that the angle theta is the inverse tangent of the imaginary part divided by the real part. And since this is in quadrant 1, we don't have to shift this angle at all. So if we plug in for A and B to these formulas, we will get back a modulus, this absolute value of Z, that is roughly equal to 5, since we are approximating here. And when we plug in B and A for this angle, we will get back roughly 15 degrees.